Okay, first question. Okay, because both of you have done this correct, I'll quickly give you the solution, okay? So original expression equals to this one. And this can be merged into 15 times square root of 3, okay? So the key point is when you see a radical expression and you want to evaluate the value of the radical expression, usually there involves 2 steps, okay? First step is to simplify. The expression. Okay. Second step is to merge. Okay. Okay. Next one. How we can do this? Okay. The method is the same. First step is to simplify the expression to the simplest form. Okay. How to simplify this? Square root of 48 equals to 4 times square root of 3, right? Okay, second one, square root of 20 equals to twice of square root of 5, right? And next one, minus. Pay attention to the sign here. Minus square root of 12 is 2 times square root of 3. Next, minus is positive. Okay, pay attention to the sign. Always pay attention to the sign here. Okay, we can do nothing about square root 5, so just leave it there. And then the second step is to merge. Okay, we can merge these two to 2 times square root of 3, right? And these two can be merged to 3 times square root of 5, right? So this is our final solution. Okay, any questions? Excuse me. No? Okay. Okay, I suggest you to make the error book after the class, okay? In the class, all you need to do is to listen to me and make necessary notes on your answer sheets. Okay, can do the error book thing after the class. Okay, next one. Okay, both of you have done this correct, so I'll just quickly give you the final answer. Okay, this is a expansion of expression. So this means square root of 2 times square root of 2 minus 5 times square root of 2 plus 3 times square root of 2 minus 15. Okay, 2 minus 15 minus square root of 2. And the final result is minus 13 minus 2 times square root of 2. Okay, any questions? No? Okay, next one. None of you have done this correct. So let's see what happened there. Okay, this is actually check your knowledge of the distributive laws. Distributive laws. Okay, so the original expression is actually 4 times square root of 2 minus 3 times square root of 6. Divide something is equivalent to times the reciprocal of this number, right? Okay, so then we can use the distributive laws. Okay, first item times twice of square root of 2 minus the second element times twice of square root of 2. Okay, and then we can simplify this expression. Okay, the first term can be canceled a square root of 2 and then cancel a 2, which leaves us a 2 here, right? So here we can do nothing about the second item. So the final result is 2 minus 3 over 2 square root of 3, right? Because this equals to, which is square root of 3, right? Okay, any questions? Do you understand? You can open your microphone. Okay. You don't have to you don't have to type here. Actually, there are microphones on your computers. Okay. But anyway, if you understand, we can proceed. Next question. Most of you have not done it. So this question actually checks your knowledge about this formula. Okay, first of all, it checks your knowledge of the operation of exponential expressions. Okay, exponential expressions operation. Okay, such as, okay, or the rule called rules of exponential expressions operation, such as if we have a to nth power times b to nth power, this equals a times b as a whole to the nth power, right? Also, we have this one, right? And also, it checks this formula, a minus b times a plus b equals a squared minus b squared, right? So according to these rules, we have something to 20^15th power and another thing to 20^15th power, right? So the original expression equals first item times the second item as a whole to 20^15th power, right? 20^15th power can be distributed to the two items here in the brackets. Okay, so we can calculate this one first, which gives us a minus b times a plus b. According to this formula, it should be a to the twice minus b to the twice, right? And this one as a whole to this power. And what's left in the brackets? 9 minus 10, right? To the 20/15th power, which gives us how many? What's the answer here? Can you see the answer here? It's minus 1 to 20/15th power, right? 20/15th is an odd number, so the final result is minus 1, right? Okay. All right. Okay. I'll give you 2 minutes to think about this. Okay. And be careful. Next time you see a question similar to this, you should not make any mistakes there, okay? Record it in your error book after the class. And think about why you made a mistake there. Okay, let's see the next one. Okay, again, both of you have done this incorrectly. So write each of the following expressions as a single fraction and simplify. Okay, when you see a question like this, when you want to write something as a single fraction, okay, the first thing in your brain should be, I need to find the common denominator, okay? Okay, of course, there are infinite number of common denominators. So the simplest way to do this is to find the least common denominator. This is very important. Okay, the least common denominator. Okay, so let's see the first one. First one, to find the least common denominator, it's better to factor each denominator. Okay, factor each denominator first, and then you can see their common factors. It helps you to find the least common denominator. Okay, do not just multiply them directly, because sometimes it will complicate the question. Okay, so the original expression here is, okay, let's factor each denominator first. Okay, for the second term, we can factor it to 2 times 3 plus a, right? Okay, we cannot do anything about the first term because it's the simplest form. Okay, the last term, we can simplify it to, okay, a squared minus 9. 9 is 3 squared, right? So here we can factor this to a plus 3 to a minus 3, right? And now can you see what is the least common denominator here? Okay, this one has a minus 3. Second one has 2 times a plus 3. Okay, the next have a plus 3 times a minus 3. So the least common denominator should be a minus 3 times 2 times a plus 3, right? This is the least common denominator of the three terms, right? Okay, and then we can convert each term using the least common denominator, okay? The first term, when the denominator becomes 2 times a minus 3 times a plus 3. The numerator becomes 2 times a plus 3, right? Because you can cancel this one to this one here. And what's left there is a minus 3 reciprocal, right? Okay. This is the first term. For the second term, one common denominator is used, which is 2 times a minus 3 times a plus 3. The numerator becomes a plus 1 times 2 times, no, we don't have 2 here. Becomes a plus 1 times a minus 3, right? Because you can cancel a minus 3 here. What's left is equal to the original ones. Understand? Okay. For the third term, when the denominator transformed into the common denominator, okay, we should times a 2 here, right? Because when 2 is canceled with the new denominator, what's left there is equal to the original one. Okay, so here, this step is very important. We convert each term using least common denominator, okay? And then you can add them up. Okay, from here, only when you have common denominator, you can add each term up together, okay? So this becomes common denominator here. What's left in the numerator? You need to calculate. Okay, for the first term leaves us 2a plus 6, right? Second term expands this expression. We have a square minus 2a minus 3, right? Oh, sorry, I made a mistake here. This here is not a plus sign. It should be a negative sign, right? Okay, so here we have a minus 12. Okay, let me check the result here. Oh, sorry, there is a mistake here too. I missed a 2 here, right? 2 cancels with each other. So this is 2a plus 6. Okay. Here. Okay, if I made an error here, please tell me, okay? Seems it's right so far. 2a plus 6 plus a squared minus 2a minus 3 minus 12, right? Okay, so here the final result is a squared minus 2a canceled. Minus 9. Okay. Okay, a squared minus 9 is a plus 3, a minus 3, and it can be cancelled with the 1 in the denominator. So the final result is 1 over 2. Okay, so sorry, Dora, I made a mistake when mark your paper. Your result is correct. Okay. Okay, any questions? No? Okay, let's see. How did the a squared minus 9 become? Okay, I'll show you how this how it works. A squared minus 9 is a squared minus 3 squared, right? Do you know this formula? A squared minus b squared is a plus b times a minus b. Okay, you know this formula, right? Okay, so here, a squared minus 3 squared, 3 is the b, right? Okay, so this one equals to a plus 3, a minus 3. So this is what I mean. If you commit a mistake here and you figure it out, then you should put this question in your error book and analyze why you made this mistake, because you're not familiar with this formula. Okay, just put the reason in your comments. And next time you meet another similar problem, you won't commit the same mistakes. Okay. All right, let's see next one. This one is 1 over 2. Okay, next one. The methods are the same. Okay, first let's factor each term. First term is x minus 1 over 2 times x plus 1, right? And minus the second term is x squared plus y squared over, okay, x squared minus y squared is x plus y times x minus y, right? So from the factored expression, we can easily see that the common factor is 2x plus y, x minus y, right? This is a common factor. This is a common denominator, and it's the least common denominator, right? So here the first term comes this one. Minus twice of this. Okay, and then because they have least common denominator now, their denominators are the same. So in this way, you can combine the two terms, and only in this way you can combine them. Okay, if their denominators are different, you cannot combine directly. Okay, so what's left there is x squared minus twice of xy plus y squared minus twice of x squared minus twice of y squared. Okay, what's left there is minus x squared minus twice of xy minus y. Okay, so what's left up there is this one divided by, okay, and then we can cancel a sum of x and y. Okay, cancel this, and the final result is minus x plus y twice of x minus y. Any questions? Emily? Do you understand? Okay. Again, put it in your error book, okay? Okay, next one. Okay, follow the same principle. First of all, let's factor each term first. First term becomes a times a plus minus b, right? And for the denominator, that's a squared, right? Okay, divided by, okay, for the next term, it's obviously that the least common denominator is ab, right? So what's left in the numerator is a squared minus b squared. Okay, do you understand? From the original expression to this step, do you understand, Emily? Okay. Then what should we do here? You can cancel a here, right? Okay. So cancel first. You can cancel as many terms as possible to make the question more simpler. Okay. So what's left there is a minus b over a times, you can convert the division to multiplication, right? Times reciprocal of the second term, which is ab. Okay, again, we factor a squared minus b squared to a plus b times a minus b, right? And then what we should do here, we can cancel a minus b and a here, right? So the final result should be b divided by a plus b. Understand? Okay. And again, put this question in your error book. and analyze the reason why you made a mistake and state the lessons you learned here. Okay, it helps you to improve. Okay, next question. Its methods are the same. As we said, you should check the least common denominator first. Okay, first item 2a minus b. Second item b minus 2a. Okay, b minus 2a is actually minus 2a minus b, right? So their common denominator is 2a minus b. Okay, let's use 2a minus b and then see what happened there. Okay, first term 2a minus b. Second term minus 2a minus b, 4a squared, right? We can put the minus sign in front, right? And this gives us b squared, 2a minus b, minus 4a squared over 2a minus b, right? And this one equals 2a minus b. So what's left up there? B squared minus 4a squared, right? Okay, should be noted that b squared minus 4a squared is b squared minus 2a squared, right? So again, you should use this formula. A squared minus b squared is a plus b times a minus b, right? You're using this formula again. So this one equals b plus 2a times b minus 2a. Right? Okay, so we put this expression up there. The numerator becomes b plus 2a, b minus 2a. Denominator becomes, a denominator can keep 2a minus b here, right? Of course, these two items can cancel with each other, which left us a minus 1 here. Understand? So the final result is minus 2a plus b. Okay, do you have any questions? Okay, do you understand what's happening there, right? Okay. Again, put it in your error book. Next one. Okay, next one. Again, first of all, try to factor each term first, okay? Factor the first term gives you x times x plus 2 over x plus 2 times x minus 2, okay? And then second term, you can do nothing about it, okay? So what should we do here, Emily? What should we do here? You can cancel this, right? Yes. And this makes this question simpler than before, okay? So here we can see the common denominator. The least common denominator is just x minus 2, not directly multiply these two items, not these two terms, okay? This is simpler than the original question. So here, because we have common denominator x minus 2, we can just combine them, which gives us 1, right? See how easy this question is. Okay. Again, if you have done this incorrectly, please put this one in your error book. Okay, next one. Again, this time, first try to factor each term first. First term, x squared minus 4 gives us x plus 2 times x minus 2, right? Okay, second term, can't do anything, just leave it there. Okay. Okay, divide the reciprocal of x minus 2 is actually multiply the reciprocal of this whole term, which is x minus 2, right? So next, do not hurry to combine these two items, because you can easily see that we can cancel x minus 2 for the first term, right? So do not hesitate, do not haste to combine the first two terms. Okay, use distributive laws first. Okay, distributive laws. Okay, distribute this item into the brackets. First item becomes 4 over x plus 2, right? And second item becomes 1 over x minus 2 over x plus 2, right? Then you can see here, these terms have the common denominator, so you can combine them now, which gives you 4 plus x minus 2 over x2, okay? And then you have 2 plus x over x plus 2. Final result is 1, okay? Again, if you have done this incorrectly, put it in your notebook. Okay, next one. None of you have done this right. But in fact, we have done similar questions at least twice, I think. Okay. So how do you think of this question? Cube root of something, okay? Cube root of something, for example, a. How to solve this? Okay, if a is something cube, okay, if a is something cube is actually something to 1 over 3 power, right? So these two can be canceled with each other. So the result under this situation is x. So what's the takeaway here? Takeaway is if we can convert this number to something cube, and the cube here can be canceled with this cube here, right? This is core thought of this kind of problem. So let's try to have a look how we can convert this number, this decimal number, to integer. Okay, minus 0.216 is actually minus 216 over how many? 100. 100 happens to be 10 to the third power, right? So we have a third here. Next, we need to check this number, right? Okay, let's see. 216. Okay, let's see how to factor this number. Okay, let's try it from a denominator of 2. What's left there? 108, right? 108 divided by 2 gives us 54, right? 54 is 6 by 9, right? Or you can rewrite it like 6 by 9 is 2 by 3 by 9, which is 2 by 3 to the third power, right? So 216 is actually, you have a 2 here, and 2 here. So 216 is actually 2 to the third power by 3 to the third power, which is 6 to the third power, right? If you are not very confident, just verify your answer by calculating this one. If this one equals to the original number, then your analysis is correct, okay? All right, so here we have cube root of 216 over 10 to the third power, which is, okay, 216 is 6 to the third power, and 10 to the third power minus 1. This one is actually minus 6 over 10 to the third power, right? And the whole result is raised to 1 over 3 power. And these two cancels with each other. So the final result is minus 0.6. Okay? Do you understand? Both of you. Okay, Dora. Dora, are you still there? Okay, no problem, right? Okay, I should tell you, this is the third time you solve this kind of question, okay? Do not make the same mistakes next time, all right? Promise me. Okay, good. Let's see the next one. Again, the methods are the same, right? Okay, because both of you have done this correct, so I'll just give you a quick answer. Note that 92.16 is 9216 over 100. 100 is 10 to the second power, right? So the key is to see whether we can factor this number to something square. Okay, this one, if you can't see it directly, just try to divide this number, use 2 or 4, okay? Okay, this time I want to make the factoring quicker, so this time I try first to use a 4, which gives us 2, 3, 0, 4, right? And then next I try a 4, which gives us 5, 7, 6, right? And again, I try 5, 7, 6 with 4, which gives us 1, 4, 4. Okay, 1, 4, 4 is actually 12 to the second power. So you have a 4 here, 4 here, 4 here, and a 12 square here. So that means this number can be factored into 4 to the third power by 12 to the second power. It's not over yet because we want a perfect square. That means something to the second power, right? So note, it should be noted that 4 is 2 to the second power, and then to the third power. We can calculate 2 to the third power and then to the second power, right? And this is actually 8 squared times 12 squared, which gives us 96 squared, right? If you are not so sure, just verify your answer. 96 times 96 should be equal to the original number here, right? So you can always verify your answer. Okay, so here the result is square root of 96 square, 10 square, 96 over 10 square, and then raised to 1 over 2. These two numbers cancels. So the final result is 9.6. Okay? Okay, next one. Okay, use similar method. First off, there is a 3 in the denominator, right? So if we can factor this number to something to the third power, and then these two numbers can be canceled with each other, right? So let's see if we can factor this number first. Okay. This is a very large integer, which can be factored to this one first, right? Okay, luckily we have a 10 to the third power here. Okay, next we need to check 16, 28. Okay, first I'll try it with 2, which gives us this one. And next we try it with a 2, that gives us 6, 8, 6. Next, try it with a 2, which gives us 3, 4, 3. Okay, 3, 4, 3 cannot be divided by 2. 3, 5. So we try it using a 7, which gives us 49. And 49 is actually 7 by 7, right? So here, actually, we factored this number to 2 to the third power and 7 to the third power, right? Okay, so this number is 2 to the third power by 7 to the third power, which is, we can calculate this first, which is 14 to the third power, right? If you're not so sure, again, you can always check the result by calculating this and compare it with 17, 28, right? Okay, you should be able to verify your answer. Okay, so the original expression is 14 cubed by 10 cubed. And then the result raised to this power. This is actually 140 raised to third power, then raised to minus 3 over 2 over 3. And then this is actually 140 to raised to 3 times minus 2 over 3 power, right? And this one cancels with each other. This equals to 140 to minus 2 power, right? Minus power means 140 squared as the denominator. Numerator is 1. So the final result is did I make mistake? Okay, let me see this. Oh, sorry, made a mistake here. I'll rewrite this, okay? 1728 divided by 2 is this one. 27 is 3 to the third power. So this number can be factored to okay, 2 to 4, 4, which is actually 3 fourths, 3, 3, which is 12 to the third power, right? So here is not 14 to the third power. Here is 12 to the third power. Okay, the final result is 14400. Okay. Any questions? No? Okay. Let's see the next one. Okay. Next one, again, let's analyze this number to see if we can factor this into something cube. Okay. Note that this number is actually minus divided by 10 to the third power, right? So next, let's check if we can factor this number. Okay, let's try from a 2. This number divided by 2 gives us 1372. 1372 divided by 2 gives us 686. Again, it can divide by 2, which gives us 343. 343 cannot be divided by 2, 3, or 5. So let's try a 7, which gives us 49. 49 is 7 by 7, right? So we have a factor of 2, 2, 2, 7, 7, 7. That means the number here is 2 to the third power times 7 to the third power, which is 14 to the third power, right? Okay, so the original expression equals to minus 14 to the third power divided by 10 to the third power and raised to 1 over 3, right? 1 over 3 is a cube root. So this means this number raised to third power first and then raised to 1 over 3 power. And this number can cancel with each other. So the final result is minus 1.4. Okay? Do you understand? Okay, both of you, because none of you have done it right. Okay, so next time when you see a similar question like this, what's the right reasoning there? You should try to convert to integer, right? First, try to convert it to the integer, and second, try to factor that integer, right? Okay, I hope you don't make the same mistakes in the next assignment, okay? All right, next question. What value of m is the following equation true? Okay, what value of m makes this equation true? Okay, if I tell you that 2 to the mth power equals to 2 to the 8th power, what is m here? Apparently m is a, right? So if we can convert the later term to 2 to something, 2 to the something's power, that means the value of m is knowable, right? So let's see how we can do this. Okay. First term, 16 is 2 to the 4th power, right? 2 to the 4th power and cubic root. Cube root means 1 over 3rd power, right? 1 over 3, right? Because something to 1 over 3 power is equal to cubic root of something. Understand? Okay. So this means 2 to the 4 over 3rd power, right? Okay, second term, square root of 32. 32 is actually 2 to the 5th power, right? And then square root means 1 over 2 power, because square root of something is actually something to the 1 over 2 power, right? Do you understand? Okay, so we can combine these two. That means 2 to the 5 over 2 power. Okay, so the right-hand side is actually 2 to the 4 over 3 power times 2 to the 5 over 2 power, which is, when the base is the same, we can combine these two items, right? Which is 2 to the 4 over 3 plus 5 over 2's power, right? This is actually 6. And 8 plus 15, which is 2 to the 23 over 6 power, right? This is right-hand side. That means 2 to the m's power. Okay, I'll write it here then. Okay, this means 2 to the m's power equals 2 to the 23 over 6 power. So you tell me here, what is m? M is, of course, 23 over 6, right? Okay, do you see how we can do this now? Okay, again, if you haven't done it correctly, please put it in your error book, okay? Because this is something new for you. I mean, something new in the error book, not something new in the assignments, because you have done it once. Okay, okay, let's see the next one. Actually, next one, the methods are the same, okay? So if we can convert this one to 5 to some sort of power, then k equals to that number, right? Okay, let's see the first one. Cube root of 25 is actually cube root of 5 to the 2nd power, which is 5 to the 2nd power to 1 over 3, right? Which is 5 to this power, right? And square root of 125 is square root of 5 to the 3rd power, which is 5 to the 3rd power and then to 1 over 2, which is 5 to this power. So the right-hand side equals to 5 to this power times 5 to this power, which is 5 to 2 over 3 plus 3 over 2 power, which is 5 to the 6, 4 plus 9, which is 5 to the 13 over 6 power. So what is the k? K is, of course, 13 over 6, right? Okay, understand? Okay, put it in your notebook. Okay, what I mean here, because Q3, question 4 and question 5 is very similar, right? If you have done neither of them correctly, I think, in my opinion, you only need to put one of them in your error book, because the types of these questions are the same. And do remember to put a star near this question. This means you have done it incorrectly for more than once. Okay, so the next time you review your error book, you will see how many times you commit the same mistakes. Okay, next one. Question 6a. Okay, actually A, B, C, D, E, F in question 6 are of the same types, right? All of them are involving simplify. And I think both of you have done significant mistakes or errors here. So be careful with these questions. Please put these questions in your error book and analyze why you commit the mistake there. Okay, let's see them one by one. Okay, the first one is the simplest one. All you need to do is cancel the same terms. Okay, 32, 24. 32 is 4 by 8, right? 4 by 8. 24 is 3 by 8. So we can first cancel an 8 here, which gives you minus. Do not forget the minus sign. Minus 4 over 3. And then you have a to the a squared b cubed c. And then b squared c and d, right? Okay, next, try to cancel ABC here. Okay, A, we cannot cancel it. Okay, B squared, we can cancel a B squared there and cancel a C here. And what's left there is minus 4 A squared and 3D as a denominator. Oh, sorry, I left the B here. Okay, understand? Sora? Dora? Okay. Okay, Emily has done this correct. So from question B to question F, it's a disaster. None of you have done anything correct here. Okay, so listen carefully. Try to avoid make the same mistakes in your next assignment. Okay. Okay. Question B. Okay. If for me, I'll calculate this first and then try to cancel the rest of them. Okay. So if it's for me, I'll just copy this original question and calculate this first. 3n, 3n. Do not calculate the result. I mean, you can just expand these expressions first, right? Or what we call a factor first. Always try to factor first. Okay? Because if you factor the terms, you can then see any common factors there, and you can cancel the common factors there, right? Okay, 3n by 3n, and here you have p and p, right? And then divided by this term is equivalent to multiplied by its reciprocal, which is mn, which is p squared over mn, right? Now let's try to cancel each term. Okay, 3 cancels with 3. N here cancels with an n. M here cancels with an M. P cancels with a P here. Okay, anything else? Of course, here is N, and cancel an N here, right? Also, P here with P here, right? So what's left in the expression? You can easily see that the only thing left there is a 2 here and a 3 here, right? Is this clear to you? At least it's clear to me. Okay, 2 by 3 is apparently 6, right? Do not make problems complex. Just expand the expressions one step by one step. Do not try to cancel all of them at once. Or okay. Okay. Next one. Okay. Again, the rule is always when you try to simplify, always try to factor first. Okay, factoring is very important operation. Just remember this rule. So let's have a look at this. Okay, try to factor each term first. Let's see the numerator first. What's a common factor there? Okay, obviously you have a 2. 2 is a common factor, right? X is a common factor, and Y is also a common factor. And then if we put 2xy in front, what's left in the brackets? Okay, for the first term, we have 3x, right? Second term, we have x. No, x is gone. We have y, right? Okay, how about the denominator? 9x squared is actually 3x squared, right? So that means 3x squared minus y squared. Again, you see this formula. A squared minus b squared is a plus b times a minus b, right? So following this formula, we factor this expression into 3x plus y and 3x minus y, right? So this means we can cancel these two terms. So what's left there? 2xy over 3x minus y, right? How easy it is. Understand? This is your golden rule. It can much simplify your problem, okay? Always try to factor the terms first. Okay, again, following same rules. Let's see the next one. Okay, let's try to factor the numerator and denominator first. For numerator, xy squared means xy, xy, right? Okay. For the denominator, you have 12xy squared. Y minus x is actually minus x minus y, right? And then you can actually put the minus sign in front. Oh, it's not very appropriate to write like this. Actually, I should write it like this way. We have minus 1. Okay, product. This is easiest. This is a product, not a difference. So you can put this minus 1 in front, which gives you minus 2xy 2x squared y, x minus y, x minus y, and 12xy squared, x minus y, right? And then we can cancel x minus y here, and then cancel a 2 here, which leaves us 6. Cancel x here, which leaves us an x. Cancel a y here, which leaves us a y. So the final result is minus x times x minus y over 6y, right? This is already the simplest form, okay? Again, if you have made an error, please put this question in your error book in case you can refer to it when you meet a similar question in the future. Okay, next one, following the same rule. Try to factor the numerator and denominator first. For numerator, we cannot do anything about it, just leave it there. Okay, 26 multiplied by a plus b. It's already been factored, right? Do not expand it. Do not expand it like this, because in this way, it's very difficult to see how to cancel with the denominator, okay? It's better to leave it as a product. Leave it as a product, okay? And for the denominator, 13, okay? A squared minus b squared is a plus b times a minus b, right? Do you recall the rules here? Do you recall the formulas? If you are still not familiar with this formula, write it in your notebook, write it in your error book. Okay? Something square minus something square. The signs doesn't matter. Something like something square minus something square. You can use square and a triangle, okay? Or you can use a circle. Doesn't matter if you're using a symbol or a letters. The key is something square minus something square equals to something plus something times the difference between these two things. Understand? Okay. Apparently, these two can be canceled with each other. And of course, we can cancel a 13 here, which leaves us a 2 in the numerator, right? So the final result is 2 over a minus b, right? Can you see how easy it is? Understand? Okay. Okay, the last question is a little bit difficult for you because by glance, it's not very easy to see how to factor this expression, right? But in our last lesson, I already told you that we can use a method called a cross product. What does it mean? Okay, we start from the coefficient of the highest order term, which is m squared. The coefficient is 1, right? 1 can only be factored to 1 by 1, right? So we put 1, 1 here. And then we need to guess these two numbers. What are the characteristics of these two numbers? Okay, the product of these two numbers should be equal to 2, to equal to the coefficient of the constant, which is 2. So that means the product of these two numbers should be 2. Okay, this gives us 1/2, only one possible factoring way, right? So we can guess. Oh, 1 by 2 can give us a 2. -1 by -2 can also give us a 2, right? So how do we decide this number? We also should make these the sum of the cross product, equals to the coefficient in the middle, which is -3. So what numbers are there? It should be -1 and -2, right? Because -1 times 1 is -1. -2 times 1 is -2. -1 plus -2 is -3, which is equal to the coefficient of the first order term, right? And also -1 times -2 gives us a 2, which is constant term, which is 2, right? Okay, so that means we can factor the expression into m minus 1 to m minus 2, okay? -1 corresponds to the number here, and -2 corresponds to -2 here. Okay, this is the numerator. Okay, for denominator, things are easier, which is m times m minus 1, right? Because m times m minus 1, if you verify, you can extend this expression, which becomes m squared minus m, right? Okay, do you understand? Do you understand how we can factor the numerator now? Okay, how about Dora? Okay, and then we can cancel m minus 1, right? So the final result is m minus 2 over m, right? Okay, before we end this class, let me tell you another example. So how about x squared minus, let's see, plus 5, 6. So how to factor this? Okay, method is called cross product. Okay, so coefficient here is 1, right? So put 1, 1 here, and try to guess two numbers. What are the properties of these two numbers? The product of these two numbers should be 5, right? So it can be 1 by 5 or -1 by -5, right? So let's try to guess these two numbers. If I put 1 here, 5 here, okay, and then by cross product, 1 times 5 plus 1 by 1 is 6, right? Which is the coefficient of the first order term, right? So that means 1 and 5 are the numbers you're looking for. So it can be factored to x plus 1 times x plus 5, right? So the 1 here corresponds to the 1 here, and the 5 here corresponds to the 5 here. Understand? Okay. Again, if you made errors here, please do put this in your error book, okay? This is very important. I should emphasize it again. The error book helps you avoid making the same mistakes in the future, okay? It's very important for you to learn math or physics or chemistry, whatever else, okay? All right, because tonight is already late, so probably I'll put the new assignment in the Google Classroom early tomorrow. You can download it tomorrow, okay? Just check the Google Classroom regularly. So have a good night. See you in our next lesson. If you have any questions, you can ask me at any time. Okay, you can send me an email or you can ask your mother's my WeChat or something else. If you have any questions, just let me know. Okay, I'm here to help. Understand? Okay. Oh, the last thing. The video of each lesson, actually I recorded each lesson just in case you need it. I put it in the YouTube. If you want to see it after the class, you can check the YouTube. I'll give you the link, okay? The link is here. In case you need it after the class. Okay, the link is here. Okay, all right, if you have no questions, you can leave the class. I hope you have a good night.